So, out of interest, how many people here have done any sort of presentation at a meetup or a conference or even internally? Quite a few people? Yeah. How many people have done like more than 5 or 10? Right, and of those 5 or 10 of you, how many of you have managed to resist the temptation of fiddling with your slides up until the very last minute? Exactly. So, we were just like texting, it's like, has he finished his slides yet? Are we ready? But sorry, in all seriousness, delighted to have Abdullah here to talk to us about agents. It's going to be a great talk. Are you ready?
Yep.
Ready as you'll ever be. So, hand it over to you then, Abdullah. Thank you.
Thank you. Thank you all. Great to be here. Yeah, the slides are still not finished. Yeah, I'd like to do a few pre-flight checks. So how's the sound? Is it clear? All clear? Slides are clear, hopefully. And I just wanted to say, I like to keep my talks a bit more conversational. I tend to feel as though I'm the least smart person in the room. So feel free to jump in if you have a question. Is that all right? Can they jump in with questions, or do they have to be a mic? Do they have to?
Yeah, as long as you shout.
Yeah, shout loud, or raise your hand if I'm in the middle of something. I'll call you out.
Just randomly shout at you.
Just make sure to repeat the question for the YouTube later so I can pick up.
Good one. If I don't do that, please call me out. Remind me. I tend to forget a lot. And yeah, even it doesn't have to be a question, comment, whatever. Jump in. Right? Correct me if I'm wrong. Today's talk's a little different. It's not super DevOps focused. It's about agents. And when I saw the DevOps meetup, I was thinking I'm not exactly sure how I'm going to fit this one in. But there's some correlation, and you can think about how to piece the two together. And it's because there's this new hype about agentic AI. So how many people in this room work in agentic AI? A few hands. DevOps related? DevOps side of things? Yeah, a few hands. So whenever there's a new hype in town, the first thing I like to do is disbelieve it. And the second thing I like to do is say, well, what's going to happen in the future? Like agentic AI has some great promises, and it's also slightly scary. There's all these promises about it's going to take over so many jobs, and it's going to, wipe out entire departments. You're going to have all these agents, and each agent will be just like a person, and they'll do all the things way better than any human, and they'll keep doing it forever, so they don't need to stop 24/7 around the clock, and they'll be much cheaper and better. So the first thing that you think is, what does the future hold? What's going to happen? Maybe it'll be full of wonderful delights and happy, sipping margaritas at the beach, or I don't know. Or maybe it might be miserable, full of terrible tragedy. Who knows? And whenever I look at the future, I can't remember who said this. Maybe one of you can remind me. They said that history is the best predictor of the future. And they say, whoever fails to read history is doomed to repeat it.
That's George Santayana.
Who was that?
George Santayana.
I believe it was George Santayana.
I read it on the internet. If I was to put a person, I'd put the internet. Thanks for that. So here be some history. This talk was originally designed to be 40 minutes, by the way, so I'm going to be a bit skinny. Do stop me if you want to dive a bit deeper into anything. So let's take a little step back. It's always good to start with some definitions. What is an agent? Anyone? Feel free to shout.
An assistant.
An assistant. I guess. Worker.
Someone who is assigned to do something. Is it true that you assign intent?
It's getting really specific. I like these formal ones. Nice.
Is it the term more like agencies? Give something being given an agency to perform a task?
I like that.
It's a workflow.
Workflows.
Or even probably let's say, similar to a junior
intern, okay, who you would actually put something on. If you need to do electricals, I'm doing research, just get him to do it, and then you can afterwards just have a review of it, and then maybe teach him at the same time.
Who listens to the instructions?
Slaves, basically. That's how people seem to think of them these days. So how does it run? Because they're not humans. They don't run on burgers and pizza and beer. Instructions. Yeah. So I mean, humans they live and breathe, and they eat and they poop. Well, how do agents live? and most of all, how do they think? So let's go back in time to a time when there was no such thing, and there was just a bunch of really smart people who wanted there to be such a thing. Let's go back to Did I jump ahead a little bit? No, that's covering it. There you go. 1969, when a bunch of clever people at Bell Labs were trying to figure out how to make computers do their bidding. And there's a whole history which I won't go over. Some of you are sure to be familiar with it, about the punch card systems and the tedious nature of making computers do things.
Oh, the tic-tac-toe system, isn't it?
Tic-tac-toe?
Yeah.
What was that one?
The punch card system. Wasn't the tic-tac-toe system?
I can't remember that one. You need to give a talk on that. Next one. Yeah, that sounds interesting, really interesting.
DevOps under 91.
91, there you go. So the Unix time sharing system, and we all here love Linux. If you don't, then I don't know what you're doing here. They were trying to figure out a way to get computers to read a set of instructions and run on a bit of hardware, and they came up with this idea of a process. And the idea of a process is that it is that thing that takes the hardware and kind of lets users interact with it through something that the user understands. It translates it back and forth. You've got the hardware layer, the CPU, the RAM, you've got kernels and complicated things in the middle. And in the end of the day, when you want to do something, you write a bunch of lines of code, and bit by bit, it gets interpreted down into the hardware. The computer listens to you, hopefully, and then it comes back with a result, and it keeps doing this over and over again. And so here now, there comes this idea of life. Suddenly, you can take a set of instructions which are dead and breathe life into it by putting it into a system like Unix. As it's running the instructions, what happens? You see, and we're all very familiar with something like this, you see a process will start. And it will start to use its computer, it will start to use its brains and electricity, its blood vessel, so to speak, to start to think. And so long as it's thinking, it's alive. And so long as it's alive, it can also bear children, have lots of children, grandchildren and so on and so forth. And it can then, when it's finished, it just sort of dies. It just ceases to exist, or it's killed. Sometimes it's killed. So now suddenly we're able to take this idea of thinking and make it sort of actually work. And these were these clever people in the 60s, 50s and 60s who were actually working on trying to make it a reality. So here we have the life and death of a piece of software. Now let's not get into the pooping bit, that we're all very familiar with. So here maybe we could say that an agent is a Unix process. Could it maybe be a Unix process? It's kind of an agent. Going back to the definitions, it's sort of a thing that you can give it work. It's certainly a slave of some sort. So there's some early, perhaps, interpretations of what we might call an agent. On a different thread, you've got artificial intelligence. So if we go back a little bit, and I always like to read the papers, where did artificial intelligence start? Where did that word first come from? Turns out there's a bunch of clever clods who were like, oh, we want machines to think and they should be like humans and do all our biddings and blah, 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 blah. And so they said, let's go meet up in this remote college. This was 1955, by the way. And let's have a think. And so they did. And they wrote this wonderful paper, which I highly recommend you read. We could ask ChatGPT to summarize it for you. That's what most people do these days.
I would just say, number 2 is science personified, isn't he?
Number 2, Minsky.
Number 2, the haircut. Just,
oh yeah, all of them. All of them were right characters.
There is more hair than face.
You should see the full picture. He's got like this old computer in front. Oh, it's fantastic. I wish I was alive in those times.
Responsible for the bandwidth equations.
Shannon.
Claude Shannon.
Shannon, yeah. Many people don't realize that Shannon was part of the AI revolution. They just think he built modems and the internet or something. So I especially want to focus a bit on John McCarthy, who was one of those 4. He went away and really started thinking about it. By the way, they were just thinking about it and writing maths formulas and saying we're really smart and stuff and we're going to invent the future. They didn't do much about it. So here he wrote a paper about the idea that machines could have mental qualities similar to humans. And again, I won't bore you with the details. I just want to focus on this idea that emerged from the paper, which is that machines, even simple thermostats, even a thermometer, can be said to hold a belief. And a belief, and the ability to hold a belief, is a fundamental aspect of the mental qualities of a human being. And he talks about some of the other aspects, but for the sake of simplicity, I'm going to focus on this one. So, how can a thermostat hold a belief?
It senses the environment and then ascribes a value to it.
Precisely. So it thinks it knows the temperature. I mean, judging by the hotels I've been, it's usually wrong. But
so I mean, you could actually say it in this way. More or less, I think he was more or less thinking in terms of that maybe he could replicate in a machine as a process all the processes of a human actually, or how humans actually think.
Precisely. This is what they were trying to accomplish back in the day, right? I mean, this is a bit later than 1959, 1917. I've jumped ahead a bit. There's a lot that happened in between. Yeah.
I mean, because in comparison to a biological being as we are, as humans, if you think about it, in comparison to just transferring all the thinking and thought into let's say, at that time, a silicon-based system.
Yeah. So they're still not quite thinking about how to make it run. They're more thinking. I mean, this is sort of parallels.
But it's more or less automation.
In a way. I mean, the paper's worth a read. I think I could give a 2-hour lecture on that paper, on how someone probably has. You can find him on YouTube, I'm sure. But yeah, it's about the mental qualities of belief, of thinking, of feeling, of emotion, and it's a wonderful paper. So he makes an interesting observation here, which is that you can't just sort of lump all these mental qualities into machines that like humans do. Like we have a central brain and we can just do all these things. Instead, it's very important that you separate them. Don't bundle them together, he says, because there's varied qualities. And the idea here is, for example, to take the thermostat a little further. You might have a machine that has a thought or holds a belief about the temperature. You might have another one which holds a belief about the time of day, and another which holds a belief about the level of sunlight, and another about perhaps whether it's raining or not. And what you see is that each little machine holds a very specific set of beliefs. If you were to try and combine all of these sets of beliefs into one machine, it would fail miserably. But if you were to separate them and have them combined together, then you might be able to build a bigger machine. And this machine might tell you, take a jacket. So perhaps agents could be said to be here emerging as this idea that an agent is a unit of thought. It's perhaps a mental quality. It's a belief. You see, there's some emerging ideas here. If we were to jump again, I mean, I've jumped forwards and backwards a little bit. It's 1971 around this time. And what was going on was that lots of people were trying to program these big mainframes. And these big mainframes were massively complicated, and these projects were taking far too long. And the biggest problem wasn't that the machines weren't doing what they were told, it's that they were doing what they were told and nobody could understand why. They were too big and too complicated. And so here again emerges this idea, which is what David is trying to talk about, is that knowledge must be broken down into little bits and that each piece should be encapsulated. The idea of information hiding, that once again, similar to the previous idea that McCarthy is trying to convey, is that don't try and stuff all of those beliefs into one single brain. Decompose them. He's one of the earliest people to come up with the idea of encapsulation or information hiding. And in fact, you're trying to do that as much as possible. You're trying to hide as much information as possible under a very clean module. So perhaps that's what an agent is? Can we say an agent's it's a module? I mean, if you think about all the systems that we've worked with, then they're all composed of modules, and each module has in some way that idea of a focused task, and it's doing its thing, and perhaps it's even running on a Linux process. You know, you've got, depending on how you architecture your system, maybe it's running on Lambda. I don't know. Here's another case, and I'm progressively going to skim through these faster and faster because it's a central idea. Here is Carl, who talks about the actor model. Right, and this is also quite interesting, but the fundamental idea is very much the same. It's that, hey, you're not going to get anywhere by trying to lump all the things into one big blob. Decompose them into little systems and have them talk to each other.
Malice.
Sorry?
No, malice.
So maybe an agent is an actor. Could say. You can also see, anyone read this book? How many people? Hands.
No, but I approve of the verse.
Oh, if you haven't read this book, definitely ask ChatGPT to explain it to you. It took me 4 months to read it. Wonderful book, a must read. Now, here you have Sussman and Abelson, who are introducing the idea, as 1984 by the way, the idea that all of compute, all of thinking can be reduced to only 2 steps. The first is evaluate, and the second is apply. Meaning, take a bit of code, understand what it means, do it. When you do it, it's going to tell you what to do next. And you just sort of repeat this infinite process. Hence this wizard holding this eval apply lamp thingy, and the concept of a lambda. That's where the lambda word came from, by the way. And again, they start talking about the same idea. That the whole thing that they're talking about is this idea that you should suppress detail, you should decompose things into little things, and someone who's one procedure calling another procedure should be able to just have a name. This is the idea of a function, right? And then your system should be composed of these very neatly designed little functions that talk to each other. So maybe an agent is a procedure. Could we say that an agent is a procedure? Maybe. Function. Alan Kay. Who knows what I'm going to talk about? Alan Kay, anyone? Object-oriented programming.
Abstractions.
Abstractions. Was that booze?
Yeah.
Good. That's because someone's been writing Java, apparently. I see a few guilty faces. Alan Kay hated Java, by the way. He hated C++, and he believed that he's the one who came up with object-oriented programming, and he believed that most of the languages that were implementing it were doing it all wrong. That's another talk. So here's the core focus that I want us to take away from this paper, is that objects are just little machines that that talk to each other. Actually, he said a lot more than that. I've paraphrased it so that you can actually understand what he's trying to say. So maybe an agent is an object. And as anyone here who has worked with object-oriented programming knows, when you start trying to make everything into little objects, you end up with a massive, I call it a ball of mud. Everything's entangled in a big, big mess, and things go terribly, right? So we're talking 1984, Smalltalk was the language, the OOP language that started all the things, and then along came all the other terrible ones. And at some point, someone named Eric Evans, anyone? Domain-driven design? Wonderful, good man. He said, well, software is terrible because you're doing it wrong, and the reason you're doing it wrong is you're not putting things in the right places. So you have to design it in a way that's very neat and tidy. You have to design it so that each object is broken down by domain.
That's sort of the logic behind Manus.
Sorry.
That's sort of the logic behind Manus and Manus, the creation of Manus as an agent.
Right, Manus.
In terms of having different domains, and then you have the manifest file that then takes from, depending on what job you want, then it goes to the domain.
Sorry.
No, I'm saying in terms of how you've broken, the history down. In terms of how you've broken the history down to it coming to the domain aspect, it kind of gives me.
You've got agents that are right.
And the
Yeah.
logic behind Manus in terms of, using the concept of domains and a manifest file to then be able to kind of do so many different jobs at once, but then it's like, I don't know, you have to clean the kitchen, you have to clean the house. There's different parts of the house that we have to clean, but the object is to clean that house, and then we can kind of figure out how we're going to clean that house, which
right.
first,
right.
what tools you're going to use.
You've got very specific domains, and it's broken down.
Sort of the logic in terms of where you just kind of talked through the history. I am kind of understanding how Manus came to these things.
Right. Some interesting ideas there. So there's some of the current agentic AI where they're starting to take some of these ideas of breaking it down by domain and so on and so forth. Nice one. Thanks for sharing.
You're welcome. Thank you for the historical context.
No worries. Thank you. So again, it's the same sort of idea, but they're saying, maybe they come up with this idea of a bounded context. And the idea here is make your objects little and make them talk to each other and make them domain specific. Don't just have them about anything. And if we go back a little bit and start to remember what McCarthy was talking about, the beliefs that each, let's call them an agent, might hold are very domain specific. It's, for example, this one should know about temperature and this one should know about this. And when you compose them together, then you might have a weather system. So you don't have these general purpose things that hold all the beliefs in one go. Here's another word that Eric Evans uses. Great book, by the way. Here again, fast forward a little, and you start to see all sorts of problems with deploying these things. And here's where we get into the DevOps territory, where you have these massive systems, and even though you've broken them down and you've got all these huge teams working on them, somehow when you deploy it, everything breaks, right? Because there's so many dependencies between things, and so you start to see these things emerge about how you might be able to separate things by domain, by task, by process, but also by how you deploy it. And we enter an era of distributed systems, especially with the introduction of cloud computing, where you've got really, really big systems, and they're all a massive mess. So how can you cleanly separate them? And so we come up with this idea of services. The service-oriented architecture, it started at SOA, and that eventually sort of evolved into the idea of microservices. Can we say that a microservice is kind of an agent? So I'm going to skip ahead a little bit to where we are now. Now we have this idea of agentic AI. And these are based on the concept of LLMs. I mean, someone thought that it would be a great idea to take all of that history and just throw it out of the window. And instead, to come up with, instead of having little machines, let's have one enormous, massive machine. And instead of having little machines that have specific knowledge and domain-specific things and have specific tasks to do, let's have one that knows everything and can do all the things. Wouldn't that be great? Science fiction, here we come. Well, it thinks it knows everything. It hallucinates a lot. So, I mean, this is an emerging field. So here's a paper by OpenAI talking about agentic AI, and what do they say in it? How do they describe this concept of an agent? They say it can adaptably achieve complex goals in complex environments with limited direct supervision. Is that much different from the definition or the ideas that were floating around in the 1950s? Is it something really new? Well, maybe. We have yet to see.
That's more of an abstraction. That's more of a philosophical idea. Everything up to that, everything you've talked about leading up to that has been a technological idea. That's a philosophical idea.
This is a lot more abstract.
That's the fundamental difference.
Yep. They do try and break it down, and I won't go into all the details. You can have a read of that paper if you wish. But what I will do is I'd like to sort of leave this here. Maybe you guys can grab a few beers and we can chat about it.
Oh, cliffhanger.
What is an agent?
It's an abstract idea.
Thank you all.
Wonderful. So, I don't know if this one's working. Brilliant. Thank you so much, Abdullah. Thank you very much to particularly Raj, to Hamad, to, sorry, I don't know your name, Lydia, for brilliant contributions. Everybody else, I think you'll agree that it really enhanced the talk. And yeah, that last minute's live Ethlin was really, really worth it. So, Abdullah, thank you so much.
Thank you very much.